Welcome, everybody. Tonight, we're going to be talking about our three project units. We have Unit 13, Unit 14, and Unit 15. And I'm just going to quickly on the sidebar here show you what we're looking at. We have the uh, project number one, which is about supervised learning, project number two, which is unsupervised learning, and project number three, which is deep learning. And then we have a extra unit, which is an extra credit unit, excuse me, that talks about the future of these technologies, and all the work within that unit is extra credit. My goal for the evening is to try to talk about the key topics. So, like most of these project units look kind of like this. We review the key material. We talk about an auxiliary topic, in this case, the project lifecycle, but we'll also talk about ethics. And then we'll look at the structured approach they have for the project, how it fits the life cycle, and how you will go about completing it. And I will tell you up front, I'm not going to work on those steps here in class. That's going to be on you, right? So this is kind of in lieu of having like a final exam. The work inside these units is a little more heavy on points, so we do have a quiz in each one of them, which is worth 1 point. We have dependency files, your starter notebooks and data files if needed. And then you have the actual project, which basically leans on the PowerPoint, which is at the top of each unit. And it's somewhat guided. The notebooks are a lot more blank than the ones that we've received in the past, but there are code examples in the PowerPoints which guide you, and it tells you where the guided steps start on which slide, which in this case is slide 28. You're free to collaborate with others within the class if you wish. You're also free to use generative AI to help you with this work. I did say all of this before, and yes, I do have faculty answers for all of these already embedded in the course. So if anybody teaches this other than me in the future, they have all the stuff available. All right, so I'm going to dig into Unit 13 right now. I think I have that relatively poised here. And I'm going to go into the slideshow mode. And here we go, flip my screens. And we are going to roll. All right. All right, so what we are going to do tonight is we're going to, at least for Unit 13, is we're going to talk very quickly about what supervised learning is and just look at the key topics and remember some of the key aspects of it, because it does kind of fade after a while. And we've been like talking about like deep learning and all this other stuff for a few weeks. So supervised learning was like a month or so ago when we talked about it. So it's kind of helpful to kind of like review the topic. We're also going to look and review the project lifecycle information. If you guys remember that was introduced in the first class. And then we're going to show you how like the projects that are structured here fall into that pattern. And it's really very applicable to a lot of IT work, although different aspects of IT sometimes look at those project steps, with a different light. But the concepts are essentially the same. And then we actually dig into the project. And as I mentioned before, I'll look at the scenario for each project, but I won't actually go through the project steps. That will be on you and or collaborators if you choose to have any. All right, so let's do a little revisiting on what this topic is all about. And we call this supervised learning, and it's, essentially, let's call it the most fundamental approach in machine learning. And its original intent really is to model how humans learn, right? And I know the silly examples that we've used over and over in the class, for example, is like when you're a small child, how do you learn what things are? Or if you're brand new to this country, you've never spoken English before, how do you learn which word means what, right? Well, somebody tells you, right? Like, for example, your parent will say, that's a dog, that's a cat, that's a bird, right? And then when you see another thing that's similar, you will have it labeled so many times that you're going to attach that meaning to that object. They indicate here that we call this labeled data, right? Like your mom or dad is saying, "Yep, I'm labeling that a dog because it's a dog," right? And they call it the least complex model, right? Okay, replicate human learning. And it's basically the point of it is to learn from what the correct answers are, right? And that way, when a new piece of unknown information is presented, well, from what you've learned, this is the correct answer, right? And that's supervised learning. Some of the tasks that go with it, well, and just to kind of refresh these things, regression, right? And this is like correlated values, basically. Um, and it says predicting a continuous numerical value. So, for example, how long will it take you to drive from home to work, depending on the distance, the traffic, the time, the day of the week, the weather, that kind of thing. Um, maybe like how your car's running might be an issue too. But that's like something where, I mean, how long will it take? Well, that's just the measure of time, right? So I can correlate it. Basically, it's measurable, right? So there's a numeric value to it. The other approach is to do classification where we're labeling something like I did before. That's a dog. That's a cat. How do we know? I don't know. I mean, I can look at it and tell you, right? And there are features of cats that are different than dogs. I mean, granted, they're very similar. They typically both have fur, both have ears, they're on four legs, et cetera, et cetera, et cetera. But what makes a cat different? And Laura, of course, you happen to have one that you can put on screen for us. Well, they're adorable when they're kittens. He looks like a little terror, but it is hilarious. So we could broadcast that, but whatever. But classification is really just kind of that, is pointing out what that is. Is that a picture of a car or is it a truck? Is it a dog or is it a cat? We're just classifying. Some examples of how we use this type of thing. So identifying credit card fraud is one, or predicting house prices. That's one. That's one that I've been kind of following here in my neighborhood, where I'm seeing some houses that are really not very nice houses, by the way, and they're selling for a fortune. And I'm like, oh my God, they're gonna spend $250,000 on that house, and they're gonna put another $250,000 in fixing it, because it's like that bad, right? So interesting, right? But hey, the houses are selling, so it tells you something, right? Recognizing digits in pictures. So in other words, you have a photograph of something and being able to identify that those are numbers in the photograph. That's kind of an interesting one. Or object recognition for autonomous vehicles. Like, how does a vehicle that drives itself realize, oh, human, stop, cat, accelerate? No, I'm kidding. Totally not meaning to say that, but it's kind of funny, right? Old person, accelerate. No. 10 points for the old person, right? I know, but that is a thing though, right? I mean, if you have a self-driving car, you need to tell it when to stop and what to stop for. A dried up leaf in the roadway, you can run that over for sure, right? Human being, stop, let them pass. I'm sure you can think of other examples. We started learning how to work with some of the libraries, and this one here kind of focuses on scikit-learn. That's one that we've used a lot. And notice how scikit-learn has modules basically in it that work with all of these key areas, right? So we talked about a couple of them, the classification and regression, right? But there's also clustering, where we cluster data together. And there's also dimensionality reduction, like when we're working with like matrices and we're multiplying them, and how we can kind of do mathematical things to simplify the data so we can process it more efficiently. And those are just kind of 10,000 foot overviews of these things. Back in week 5 and 6, wow, that was a long time ago, right? Like forever ago. We looked at KNN, like the nearest neighbors, right? That was for like classifying things. We also looked at SVM, the support vector machines, and decision trees, and just kind of quick recap of each of those. With KNN, we looked at like when we're, putting data together, like what does it belong, which group does it belong to? We use what we call a K number, where we're trying to like do a fit of like 3, in this case 7, and you can go anywhere from one up to maybe a couple dozen, something like that. But usually you want to use generally kind of a small K number for these things to make the classification as accurate as possible. And hopefully you guys remember all that. And that way, when we get a new piece of information, we can make a better determination. Where does it really fit? Does it fit with the green triangles or the red stars? Which one is it closer to? Which one is the nearest neighbor, right? So that's where the name comes from. We also had the SVM, and with this, we're trying to find basically, I guess, a best fit, and they call it a best fit maximum marginal distance. In other words, how do we, know the difference between a basketball and a soccer ball or a football, right? If you're a European, maybe we talked about that too. And what we typically want to do is we want to take that difference between them and find the maximum difference so that we can really understand where they are different. Now, for those of you that have used these types of balls, basketballs have a texture, right? They're also typically orange, but not necessarily, right? And they have like that certain striping that they have on them. And soccer balls have that hexagonal pattern, or is it hexagonal or five-sided, whatever, pattern, usually black and white. Doesn't have to be those colors, but those are pretty typical. And there's other differences, I'm sure, but we're looking for what the maximum difference is in order to be making a really clear classification. We also learned about decision trees, and decision trees, there's, the structure, and we can generate these with code, right? And we have the different aspects of a decision tree. Usually we have the root, we have nodes that are in the middle of the decision tree, and then we have the ones at the end that we call leaf nodes. And then they were also recognizing there's a kind of like what we call a parent-child relationship. But information can be broken down like this to help us navigate decisions based upon, certain key aspects. And if you guys remember, there was like math that we could do to determine what the starting point is. Remember all that stuff? And we can also generate these with code. There were other models, right? I'm not really super worried about those. I'm going to call the ones that we looked at, those are really the key ones for sure. All right, now we're going to take a look at the AI project cycle. Chapters 14 and 15, by the way, don't talk about this piece. So they talk about ethics, but we're going to review this. This comes from our first course, by the way. And as I mentioned before, working in within a project methodology is very, very common in IT. In some companies, it's highly formalized, and they have a very structured, what we call waterfall approach, system development lifecycle. It's usually drawn as a circle, by the way, not as kind of a straight line or jagged line like this is. But they do indicate here that it's a cyclical process. And, they're trying to apply this to data science project. And it's really kind of similar, frankly, to other project methodologies, except for the fact that we're dealing with kind of different things when we do AI or data projects compared to like traditional software projects, because, often these require information, right? So we have to have the data to start with, and then we're building models that are hopefully accurate. So that's kind of a thing, right? Which is different than other typical things. But the whole point of it is to go through this process, and it is a process. So let's go through each one, right? First, you're usually presented with some sort of a problem. So it's like, what are we trying to figure out? What are we trying to overcome? What solution are we looking for? Are we trying to maximize profits or minimize cost or make, the least amount of scrap and manufacture, whatever that thing is. We have to be able to tangibly identify it. You cannot solve a problem unless you can define it. It's really as simple as that. So We call that problem scoping. So from there, we start to gather relevant data, right? Um, and this can be daunting, right? Because if you're trying to gather real world data and it doesn't already exist, well, you have to figure out a way to capture it, right? The other thing that we learned is that using generative AI, we can also create synthetic data. You guys remember that, right? So we can use real data to help generate synthetic data that will help us train our models. All right. From there, we start to explore the data. So in other words, we look at it, we evaluate it, we create visualizations of it. And sometimes, especially with visualizations, what you can look at a whole bunch of numbers and it's like I'm not seeing it, and then you just make a simple chart or graph or scatter plot or a pie chart or whatever, and then it becomes a lot more apparent what the impact of that data is or how valuable it is or how insignificant it is or whatever. And you'll hear me say over and over and over again, people will present you with lots of information in life all the way through your life. And a lot of people just go, okay, whatever, and just roll. They don't really look at the information. As data people, AI people, you got to look at your data, folks. Evaluate it. Don't just take it even for being accurate. And I think I've given you enough examples of that, even within my work here. Often people will present you with information and it's not even accurate, right? Just hoping that you won't even notice. From there, we go into modeling. So once we have data that we think is good and an adequate amount of it, then we start to build or apply is a better word, mathematical algorithms to basically adjust our machine learning model to give us the results that we want as accurately as possible. And this is a modeling process. We will take a portion of that data, if you guys remember, and we'll use it to train our model. And then we'll have a portion of the data to test the model. And then we learn later with deep learning that we even reserve another portion of it that kind of recycles and fine tunes the model within itself in a recycling pattern, right? The whole point of it is to get as accurate results as possible. And there's a lot of different ways to accomplish that, right? As you do that, we start to evaluate, is this model good? Is it accurate? Does it need to go deeper? Does it need more or whatever? Does it need less? Does it need a revision to the algorithm? Are we seeing it correctly? Do we need more data, right? We evaluate and we figure out which is the best way to do it. Once we have that best way, or what we think is a functional model at least, then we can deploy that. I mean, to get it out to wherever it's going to be utilized. That might be internally in an organization. It might be public facing via a piece of software, like who knows, right? It depends on what the project is, but you put it into place and then you deploy it in whatever manner that item should be deployed. All right, so what I'm going to do right now is we are an hour in, so we're going to pause. We're going to come back and we're going to look at how the first project kind of structure is, and I'm going to rifle through it really fast, and then we're going to switch over to units 14 and 15 and look at that content. So 5-minute breaks, folks. So I'm pausing the video for now, and I'll see you in 5. All right, we are back from break, and we're going to talk about how these projects are going to work. So once again, I'm not going to do any of the project build here. I just want to show you the lay of the land and how the slides lay out and how guided it is, right? So you will have that starter notebook that comes in the dependencies file for each unit. And as I said, it's more blank than typical. And basically you'll be presented with the project. Now you'll notice here, and one of the reasons why I'm totally okay with collaborating is this is how they kind of do it with the Intel training. And what they suggest that you do is that you do work with others if possible, that you try to figure out the code on your own first, and then take a look at the sample answers and then see if you can get it to work. I want you to notice that last bullet though. It says, at the end, you will need to fine tune your models and get a model with the best results. So just because they're giving you code doesn't mean it's the best code. You guys feeling me here? Right? They're giving you stuff that works, but not necessarily the best. So you might have to do a little bit of research. And once again, generative AI is acceptable, but you can look back at our previous materials and see how we tweak things to make them optimal for the different scenarios. Just putting that out there. So here's our first scenario. It says about 1 in 8 US women, about 13% will develop invasive breast cancer over the course of their lifetime. In 2021, estimated 281,000 cases are expected to be diagnosed in the US, along with 50,000 of non-invasive. Timely response is crucial so that real invasive cases are treated promptly. While we do not put those non-invasive cases on necessary, okay, whatever. However, there's a crunch on professionals to check on the reports. Is there a way to overcome this problem? And I think this is kind of an interesting scenario. So in other words, you should test all the time, but then you have to have somebody read the report. And because people are testing all the time, there's not enough people to do it, right? So that's kind of a scary scenario. This is a common problem in healthcare. All right, so then what they do is they're putting us through the project steps. And what's the first step? Understanding the problem, right? So, all right, we need to find out what is the actual problem and write a problem statement out. We need to define it, right? So ideally you would do that. So here, for example, they have a sample answer, and I'm not going to read it, but it's there, right? And when you turn in your work, I don't want you to write exactly what they've put here. I really want you to put it in your own words, and maybe you say it a little differently. Maybe you would describe it a little differently. All right. Then you gather the data. All right. Where's your best possible source of information with this? And then looking at the CSV file that's provided, which column in there is the target? All right. And then so you start looking at it and they start defining it. And here they're pointing out a certain piece of information, right? So I'll let you guys read that on your own. The data file that you'll get presented with has a lot of information. A lot of it is kind of cryptic and not friendly looking, right? And what do these numbers mean? We don't necessarily know. I mean, maybe we can figure that out. And these columns aren't all clear or whatever. But ultimately, we're looking for a diagnosis. And remember, every feature, like every column, is like a dimension for data. I mean, and there's a lot of columns here, right? So it's a very, very rich data set. How many columns are there? Features columns. How many rows of information or records are there? And is there any information missing anywhere? I can tell right off the bat, like right here, there's a piece of missing information. What's the deal with that? Can we use that piece of information, or does that break things? Or here's another one that's missing, or maybe there's a reason for that. We don't know, right? So you got to get the data, and then you have to explore the data. So one way to explore the data is to import some of these libraries and basically build different models to see like which ones are the best. So you're gonna have to read in the CSV file, and then which approach are you using? KNN, SVM, decision tree, etc. Right? And you'll notice here, that you can try all of them actually, right? So you can do KNN, you can do SV, and you can do the decision tree, and you can feed in your data set. As you look at your data, is there data that's not there? And how did you identify them? I just looked. That's how I did it. And there were blanks. Now, what we have learned subsequently is there are coding ways to figure it out too, because you can run code to see if there's missing data and you can just ignore it. So that's a thing. Sometimes you can extrapolate data from other fields, and I'm not sure if that's worth doing, but sometimes it is worth doing. It just kind of depends. So those are things that you ask yourself as a data scientist or an AI person, for sure. All right, so you can start to run some code then basically to figure out if you total stuff up, what it leads to. You can also use the is null thing to figure out what's missing. That's kind of one of those functions that helps you with that. And then it'll also ask you, how did you figure that out and how did you fix it? Right. And they have an example here of how to proceed with that. They also have some sample answers for going forward. And I'm not going to read through all these. I don't want to give away the answers necessarily. And then once you've fixed all those issues with the data, then you basically reprocess it or pre-process it. And then can you adjust the values if you need to? All right. And then we start to set a target, right? So this is one of the sample answers. So which is which diagnosis? Well, you have to figure that out. But we do have a sample. So M is malicious and B is for benign, right? And most are benign, which is good. You also might want to visualize the data. So you might want to create some graphs and look for correlation between the features or dimensions, and then which ones have the highest correlations. And then knowing that can help you kind of run your code. Here's an example of an output, and this is one of those visualizations that we have tinkered with a little bit. You can see this is a large data set, so the visualization is a little bit larger. And that's one little caution. I know there was one of the data sets, I think it was the deep learning one, that was really, really large. So be very patient in downloading it, very patient in unzipping it, and then very patient in processing it. I'm just giving you that warning. I've played with the data set a little bit, and when I download it, I'm like, oh my God, it's half a gig. Oh my God, when I decompress it, it's over a gig. Oh my God, when I process it, it really takes a long time. So, when you process the information, be patient. Like when you're running a cell, maybe you want to go for a walk, or, run it at night before you go to sleep and then come back in the morning and see what it did, that type of thing, and see if it worked. It can be very agonizing to watch data process, especially when the data sets are large. And this is why we need big data centers, folks, that are powerful to do this work, by the way. Some more sample answers here, right? And they kind of keep going through this process. And I'm just kind of like move on to the next thing here, but they have a whole bunch of stuff just based on data exploration. And then we finally get to the modeling, and we need to figure out what's the right model for these scenarios. So we're going to do one for each, right? And figure out which one's going to lead us to the best thing. So how do you know which one's best unless you compare, right? How do you know which car to buy if you don't test drive it, right? Right. So not all of them are a good fit. So they show you how to do KNN, SVM, and decision tree, right? All of those. Then we evaluate, and what is the best one, and how do you do that? Well, we have to look at the metrics for each one, right? So there's code that we can run to check it, right? And notice the accuracy and all that. Then we have the SVM, and that also has output. And then we have the decision tree, and that also has output, right? And then we can look at that. And now at this point, right, so you were kind of guided there with sample answers, but you still might have to tweak some of that code. And that's the fair warning here. If you're not sure what to tweak, my tip is go back to the previous stuff that we did and see which adjustments did we make, right, to make the code more optimal, right? And that's really going to be your task here. So that's like the deeper dive. You can, once again, also ask Gen AI if that you feel that is the best fit for it. All right. Oh, I guess I missed one more section here. I'm just going to bring this back over. There's also the deployment piece. Like once you figure out which is best, then you go into deploying it. And then you figure out like which one we think is best. And then you would write your answer. based upon your results. They're not giving you that answer. I want you to notice. You got to come up with that yourself. All right, I'm going to move now to unit 14, and now we're going to kind of do the same process we just did. So this will be somewhat accelerated, I guess. And you know what? I'm not even going to do it in slideshow mode here. I'm just going to do it in like this mode, if you guys don't mind. And so we're going to look at unsupervised learning, AI ethics, and then it'll go through the project steps. But I'm not going to step through the project steps this time. I think you guys kind of got a feel for how that goes. I just want to look at these topics. Then we'll look at the unit 15 topics. And then hopefully we'll be done by then. We'll see. All right, let's go back to this. All right, so this is the stuff we're going to look at. And let's see if we can do a little recall here. All right, so it says unsupervised learning refers to learning without a ground such as labels. So in other words, the data is not necessarily labeled, right? It's not like a parent telling their child, that's a dog, that's a cat. You're just presented with a bunch of different things, and maybe an image, for example, and then you got to go, well, these are kind of the same, and these are kind of the same, right? And if we have the right kind of algorithm, we can basically look at our samples and then kind of group them together, and then we can get a new sample and then guess which one it fits with, right? That's kind of the point. All right, so no label data here. Right, so like we can't, because we don't start with label data, we're just looking for how we're grouping these together for the most part. And of course, the more data you can provide as an example, the better this type of model is going to do, right? If you only had one picture of one dog and one picture of one cat, that's not going to be very conclusive. If I had a million of each, that's going to be a whole lot better, right? And I like the last bullet here, says the future of AI in large part depends on getting better at unsupervised learning. In other words, analyzing data that isn't labeled. Right. You guys remember we used a lot of like interesting examples, including the Netflix thing. Like, how does Netflix know what to recommend to you? Well, the more stuff you watch and the more stuff you like, well, then it starts to figure it out, right? Like if you're always, clicking on, I don't know, romantic comedies, chances are it's probably going to show you more romantic comedies, right? Or if you're look at like sci-fi, it's going to show you more sci-fi. Absolutely, right? So if it's starting to recommend things for you, right? How is it doing that? Well, this is why they like it, at least Netflix does, when you click like or dislike. And I don't know if you guys remember the old days of Netflix where you could rate it on a star system, like 1 to 5. And now it's just good or bad, like or dislike, right? Which one's better? I don't know. I think the problem that they had with the star system is like, that might be in the category you like, but it's not getting really high stars, so nobody's watching it, right? Where now they're just maybe classifying it a little bit more broadly. I think that's kind of the general lay of the land. So they don't really have any goal for making a recommendation aside from like basically what you've done in the past, or what you've declared as your actual interest. And really what they're doing is they're just noticing your pattern and how you're doing it, and then they're just basing it upon that, right? And we've talked about this. So really what they're doing is clustering, basically. And it's based on observations, your activity, your likes and dislikes. All right. Now let's flip over to this topic here. We'll talk a little bit about AI ethics, and this is going to be recurrent in the next one too. And we'll talk about what it is, some of the categories, how it's applied, and then what we call explainable AI. It says AI ethics is a set of values, principles, and techniques that employ widely accepted standards of right and wrong to guide moral conduct in the development and use of AI technologies. I'm going to play this video if you guys don't mind.
There has been a kind of sea change in AI over the last 5 years. Before that, had you asked seriously whether or not we should be crafting a code of ethics for artificial intelligence? As we've seen AI begin to be applied in real applications in Facebook and in self-driving cars.
Now is the time to be talking about these issues, and we are the people who will be deciding what society looks like for our children in an AI and roboticized world.
Over time, software is going to be written by software. AI is going to create the AI. So
let's get a code of ethics that really prioritizes ethical considerations at the beginning of design, and that will help both the creators of the technology and then certainly the users, because there's a better sense of value alignment for the technology and the people using it.
There is no one universal set of ethical principles, so it will be already very important to try to identify the right values to be used in a particular scenario. And then once you have identified them, of course, you need to understand how to model them and how to embed them inside the AI system that you want to develop and deploy.
When it comes to a split-second decision that will potentially involve a necessary injury or death, and there are trades, what will an automatic car do? This brings to the fore this notion of ethical models in our systems, and whose ethics are they?
We create these technologies, and we need to choose how we want to use them, or otherwise we will be used by them.
This idea of ethics is really this glorious opportunity that we have as humans right now today for deep introspection.
The awareness and the intent by creators of this technology is to not be blind, to not ignore those negative possibilities, but to understand them up front, make the world aware of them, and do what we can to mitigate their impacts.
How do we represent our values in these systems such that the systems are aligned with us? They would make the same decisions we might make had we had a long time to think about it.
the power of these AI systems is going to be that they do infer a lot, that they will know us better than we know ourselves. We'll be tracked in a lot of different ways with some kind of underlying goal. Is that goal to sell us products? Is that goal to make us more educated, to make us more civil, more open-minded? It's potentially an indoctrination machine. And how that's governed, who runs that, is that going to be strictly for commercial purposes? That's, I think, one of the key questions. This is too powerful just to sell lawn chairs to people. This changes the way you look at the world. So it would be good if it were taken that seriously, I think.
How will machines know what we value if we don't know ourselves?
All right, really interesting. And I want you to look at the date on this. This is like a full 7 years ago, folks, right, that they're talking about this topic. And I think it's really fascinating because we've had a recent thing happen here in the US. And I don't know, like, if a lot of you guys were tapped into this, but I forget which day it was. There was a headline that came out that Trump signed an executive order that affected AI in a couple of different ways. One of them being he told AI companies, don't worry about copyright laws. Just go ahead. Basically, that was, I think, one of them. And the other one was to strike information relative to quote unquote woke culture from any AI models used by the US government. Right. So, and I'm not making any judgments on this. I'm just telling you information. You guys can go read up on this yourself. And aren't they addressing exactly some of the issues they're talking about here? Yeah. And whether you agree with the steps or not, right? The Atlantic Review, right, which is a really major kind of like editorial type publication, their headline after that executive order or orders, I'm not sure if it was one or many, was something like, and don't quote me on this, I think it was like, Trump just gave AI companies a gift or something like that. He was basically lifting a lot of barriers for them. But he, at the same time, right, so whether you see this as positive or negative, there's this recognition from our government that these technologies are really important, that the ethical principles behind the models that we use are important, right? And I think they were addressing it here in this, and this was like a full 7 years before the stuff is coming into play, how much this stuff has changed since, you know, this conference that they're promoting back then. I think that's pretty fascinating. All right, let's move on. Categories inside of ethics, so like transparency, justice, fairness, non-malevolence, responsibility, privacy, benefits, yada, yada. You guys see all the different stuff there. And these are all issues that we wrestle with. And really kind of like the same kind of stuff we wrestle with as human beings. And I think another really fascinating thing, you know, as I've been talking about some of these topics with a bunch of different other IT people that I work with, or people that work in the industry, and the impact that it's already having on the workplace and our futures. And we kind of went into this conversation, by the way, which is kind of, you know, we're talking about Netflix. And I'm like, you know what, this kind of reminds me of that Battlestar Galactica series, you know, where the robots rise. And it's kind of like Terminator 2, with Terminator went into Skynet, and Battlestar Galactica kind of went the same way. We created like robots and artificial intelligence, and then they got smart, and then they started killing us and taking over. But I thought it was really fascinating in the Battlestar Galactica series, and I was recalling this about it, is that the robots there evolved to the point where they included biological components in their technology because they found it was more efficient than the electronics, and they were basically creating themselves as humans as they got smarter and smarter, right? And the humans no longer believed in God, but the robots did, you know. And I thought that was a really kind of an interesting premise of that show. If you guys have never seen that one, that's one that you should see, because it really kind of asks some really big questions, and I really kind of enjoy it. All right, I'm going to play this video also. And I'm trying to look at the clock here and make sure we're being efficient. Let's go ahead and run this one. So here goes.
The term artificial intelligence, or AI, can seem so futuristic and mystifying.
Oh, sorry. I'm trying to change the speed, not restart it.
The term so futuristic and mystifying. But what if I told you it's already part of our daily lives? No matter where we are in life, AI has impacted our daily lives. From automated customer interactions, improved personalized shopping experiences, and operational automation, AI can be implemented seamlessly to improve our way of living. AI has proven to streamline businesses, client experience, boosting productivity, and thus increasing revenue. Whilst all this talk about AI may seem new and exciting, it also raises a concern regarding its ethics. If AI is not deployed properly, it could cause harm, damage reputation, or contain legal risks. Technology itself is neutral, and it is important for people and organizations to understand and be accountable to the risks involved in AI application and implementation. The development of AI must be human-centric, with fair outcomes, ultimately aiming to enhance our quality of life. It must also be transparent and explainable, where the purpose of the AI program is clearly stated and easy for users to understand. Thus, professionals in AI ethics have built a comprehensive authoritative book called The Body of Knowledge, or BOK. It aims to serve as a guide that defines what is considered ethical implementation in the field of AI technology. Ultimately, AI, as with any tool or entity, when used reliably and honestly, can help improve our lives while building a dependable platform for which we as a society can build our future upon. That is why it is important that we focus on understanding AI ethics and implementing it in a principled manner.
Now, how you feel about that is kind of an interesting scenario in and of itself, right? Because who's to say that people have to follow a code of ethics in anything that they do, right? Like even within our society here, people have very, very different ethical standards for how they approach situations, in life, in business, in government, in war, in, whatever, right? So I think these are really big questions. I would hope that big companies are building ethics into their models, but how can we really be certain of that? Do we take them at their word? Or are we the ones that will develop those ethics? Is it too late already? These are great questions. We don't know. All right. Examples of ethics cases. All right. Autopilot mode in the car, right? Braking for pedestrians. We hope so, right? Hopefully they're not trying to rack up points, right? And so they argue if the car can prevent a collision, then there's a moral obligation for it to override the driver's actions in every scenario. Now, we see this in cars that even don't have complete self-driving, like automatic braking, for example. And I don't know how many of you might happen to own a car like that. But do we really want a car to make that decision for us? Or is it our choice whether to kill somebody or not? Or, here's the other scenario. You're gonna kill either the group of old people on the right or the young school children on the left, right? One or the other is going to happen. Which one do you choose? Yeah, right, exactly. So these are very, very difficult to kind of think about. And sometimes, they have to use metrics to determine this, right? So they do, as silly as it sounds, they do have to assign a point value to like which one is more susceptible or the right choice, right? And it's kind of terrible to think about taking ethical questions and applying numeric values to them. But that's kind of what we have to do to make a model work, if you think about it, right? Because they operate on math almost exclusively. There's also this concept of explainable AI, and that is, right, the first bullet there is basically that we get to the point where we trust our AI and the output created by these algorithms to be right or true or accurate, right? And it says explainable AI is used to describe an AI model, its impact and potential biases. And so we're not discounting the fact that the AI might make a biased choice. It helps characterize model accuracy, fairness, transparency, and outcomes. All right. And I think, yeah, and these are kind of issues that we face. Like if you have the option, right? So like I give you guys the option to use Gen AI to help you with your work. But if you, let's say you take an English class or a math class and your instructor says, you better not be using AI. But now you're getting used to using it. Yeah, no, like where do you, so you just use it and don't tell them, or you're still using it on the side, but you're claiming it's your own work. These are like some deep questions, folks. All right. From there, it goes into the project scenario. Let's just look at the scenario here for this one. This one is a recommendation engine. It's kind of not too dissimilar from the homework. So for example, it says before recommendation systems are out there, the major tendency was to take friends' suggestions. And I think about this, right? Like the old adage of like, you go somewhere and, you're unhappy with like your customer experience or something. And what do? If you like a place, you tell 10 of your friends. If the place screwed you over, you tell 100 people, you post it on Facebook how terrible it was, right? So like you would just often take a person's word on it. Recommendation systems here says it helps organizations create loyal customers and build trust in desired products and services. And a book recommendation system is where we recommend similar books to the reader based on interest, kind of like the Netflix things. And then you can get, books that are matching your topics based upon these things. So this is the scenario for this project. All right, I am now going to move on to the Unit 15 PowerPoint, which I think I have pulled up. And once again, we're going to hit the key topics here, and I'm going to do it in this non-slideshow mode. If you guys are cool with that. So this time we're looking at deep learning, a little bit more on AI ethics, and then a really quick look at the project. So let's dive in here. Okay, what it is, when do we use it, examples, and sample applications. All right, so as we've learned earlier in the semester, machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So it's like machine learning squared or something. It is based on this concept of neural networks. Deep learning will have that input layer and output layer, and then hidden layers. And when we have 3 or more total layers, then we call that deep learning, basically. The concept is basically to mimic the behavior of the human brain. It doesn't really do that exactly because we're doing that, with mathematical models and algorithms. And it says here, a neural network with a single layer can still make approximate predictions. Hidden layers also help to optimize or refine for accuracy. It's a field that's based on learning and improving by examining its own algorithms, basically. So there is that kind of like recirculating aspect of it in some cases. When do we use this? When we have a lot of data, and we're talking like not a large data set, but a monstrous data set, right? And the project in this unit has a monstrous data set because that's, otherwise, how do you really do deep learning on it if it's not a large data set? When the problems are also complex, right? And usually it's involving things like image classification or object detection. By the way, topics that will be revisited again when we do natural language processing, which uses a lot of these technologies. So that's in the next course, by the way. Example of deep learning models, and I don't know if you remember, we did work with some of these, and some of them we just talked about. So convolution, neural networks, the LSTMs, RNNs, the GANs, the RBFNs, multi-layer perceptrons, self-organizing maps, and some of these we didn't touch, but we did talk about all of them, if only briefly, but some we did spend quite a bit of time on. Example of deep learning applications, language translation. This is really kind of fascinating. We'll talk about like timing. I recently got a notification from our, I forget what we call it on campus, Learning Success Center, which, like, for example, if you are looking for tutoring help, or if you are maybe disabled or need some sort of accommodation, that's a department that kind of helps you. One thing that we see a lot of is we get a lot of people that don't necessarily know English that well, but they still want to go to school, right? And now, while like I don't know Spanish well enough to deliver a class in Spanish. In fact, I barely know it well enough to order like a decent meal at a restaurant. I wouldn't be the one to translate. But the school recently bought some devices that students with accommodations in place can borrow that do live translation. And the first thing that popped in my mind is like, oh, they can sign out this device, take it with it to class, and then as the teacher is talking, it translates it into their native language. Like, wow. Can you imagine? Like, holy cow, right? And what does it sound like? All right, so I'll say it. It sounds like Star Trek, right? The old original Star Trek series, like they wear those like communicators on their chests up here, a little like logo, and it was a communication device, a tracking device, but it was also had built into it a universal translator, and like an alien would go blah 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 blah, and it would translate it to English, like beam me up, Scotty, or whatever, right? And here we are, now they're making devices like that, and you can sign them out at school. Like, holy cow, welcome to the future, folks, right? Colorization of black and white images, adding sounds to silent movies, automatic handwriting generation, interesting, autonomous vehicles, demographic and election predictions, news aggregation and fraud news detection. That's kind of an interesting one. Didn't Facebook just turn that off? Now you can put fake news on Facebook again. Virtual assistants, right? So like Siri and Alexa and all those things. Visual recognition, fraud detection, and healthcare. So it's used in all of those areas. All right, now let's take a really quick look at ethics again. And this is kind of expanding on what we just did. And I think, all right, so that's the same video. You guys remember, right? So I think this is just a repeat. Yeah, this is all a repeat. So like, I feel kind of silly pulling it up now. All right, this is all repeat. So let's just go right to the project. Let's look at the scenario. The scenario on this one is this. It says more than 38,000 people die yearly on U.S. roadways. U.S. traffic fatality rate is 12.4 deaths per 100,000 inhabitants, and an additional 4.4 million are injured seriously enough to require medical attention. Those are pretty astounding figures. Have you guys ever driven down the highways here and they have those info signs like on the interstates, and they'll say, there's been, X number of traffic deaths in Wisconsin this year, buckle up, that kind of thing, or don't drink and drive or something like that. And that's all very sage advice. Okay, this brings with it the utmost importance to introduce autonomous vehicles to keep people safe. So they're making a contention here that if we switch to self-driving cars, these accidents probably wouldn't happen, right? Well, think about it. If I go out and I have a bunch of cocktails and I let the car drive itself home, I don't have to worry, right? Yeah, that would certainly save some lives. It says, however, to truly keep people safe, vehicles must be able to recognize the traffic signs and act accordingly. All right, here's a classic problem in Wisconsin, right? Doesn't happen down south, for example. Driving down the freeway, it's snowing, right? And it's that wet, sticky snow, and then the signs get covered up. Was that my exit? Or what is the speed limit? You guys ever have that scenario? Yeah, right. That's really bad, actually. And so it says, you are an AI engineer with DriveSafe, a company that builds autonomous vehicle. Your current task is to train the vehicles to recognize the traffic signs. Now, we might not be able, for example, to read the words on a traffic sign if snow is caked onto the sign, right? But a stop sign is a certain shape. A yield sign is a certain shape, right? And we might not be able to read the speed limit sign, but if you use your GPS to drive around, and you have to assume autonomous vehicles do, they have a database that they know what the speed limit is in any given scenario. And I don't know if you guys have ever tested that with your GPS, but that's kind of the breakdown. As with the other projects, they sequentially take you through all the project steps with sample code and materials. I do want to reiterate that if you want to opt out, so this is units 13, 14, and 15. Unit 13's project is 8 points. Unit 14 project is 8 points. And then the one for deep learning is 6 points. And if you don't want to attempt this one, and the one reason you might not want to is this data set is particularly large. And I don't know if I indicate how large it is here. I think I have to click in there. Yeah, so I say this is a very large data set. Zipped, it's 630 megs, which is huge, absolutely huge, right? Mind you, this is like a CSV file or a collection of them. It is not small. So it takes a long time to download it, takes a long time to unzip it. It takes a long time to process code on top of it. So whenever you do any of those actions, wait. Don't go, it's not working, and restart your computer, right? Because you're going to go back into the same scenario. If you have a computer that's as powerful as possible, this is why you want a lot of RAM, a lot of processing power, and hopefully a lot of time. Also, be patient with it as you're doing the processing steps. If this seems daunting, I want you to be mindful of the fact that you could go to unit 16 and do the extra credit unit instead. So there's 6 points on this paper option. There's 3 additional points on the presentation, and there's an extra credit quiz as well. So those can be used to replace your work. I do plan to record a lecture on this material, and maybe I'll just do that during the next session. But folks, that's basically the material for the evening. So this recording ends here.